Problem 108 on page 12 of the book Strength of Materials by Pytel and Singer. An aluminum rod is rigidly attached between a steel rod and a bronze rod as shown in the figure. Axial loads are applied at the positions indicated. Find the maximum value of P that will not exceed a stress in steel of 140 megapascal, in aluminum of 90 megapascal, or in bronze of 100 megapascal. Okay. So we are given the allowable stresses in each of the material. The allowable stress for steel should not exceed 140 megapascal. For aluminum, it should be less than or equal to 90 megapascal, and for bronze should be less than or equal to 100 megapascal. So what we're going to do now is to determine the internal force, the normal force in each of the materials. So what we need to do is to cut a section. Let's call this section AA. And we draw the free body diagram of that bronze part, this one here. So we have the force 2P, and it is going to be resisted by an internal force, internal axial force. Let's call it NB for bronze. So by summation of horizontal forces equals 0, we get N sub B minus 2P equals 0. So our normal force is equal to 2P. The stress is given as equal to the normal or axial force divided by the cross-sectional area. We are also given the cross-sectional area for steel is 500 square millimeter, for aluminum is 400 square millimeter, and for bronze it's 200 square millimeter. So from the stress formula, the stress for the bronze is equal to the internal force N sub B divided by the cross-sectional area A sub B. So we're given stress subscript B equals 100 megapascal. Then our NB or N sub B is equal to 2P, and our area is 200 square millimeters. So this is megapascal, this is square millimeter. P should be in Newton, and that is equal to 10,000 newtons, or in kilonewtons, that's 10 kilonewtons. So that means the bronze rod can support up to 10 kilonewton of P. Okay, next we cut a section at the aluminum rod. Let's call this section B. So by the way, this free body diagram is for section AA. So considering section BB, our free body diagram now becomes like this. Okay, this is the bronze and this is the cut portion of the aluminum. So there are now two external forces, P and 2P. Then this will be resisted by an internal force. Let's call that N subscript A for aluminum. Okay, so again, summation of horizontal forces equals 0. Considering forces to the right as positive, we have NA or N sub A plus P minus 2P equals 0, and our NA equals P. And then sigma sub A is normal force subscript A, and the area for aluminum or A sub A. So this is given to be 90 megapascal equals NA is P, area is given to be 400 square millimeters. So we get our P equals 36,000 newtons, or that is 36 kilonewton. And then for the steel, cut a section here. Let's call that section CC. So at section CC, our free body diagram will look like this. That is for the steel, this is for the aluminum, and this is for the bronze. Okay, so we have external force here that is equal to 4P, and then we have another one here equal to P, and one more here equal to 2P. Okay, so again, Our internal force resisting all this external force will be N sub S for steel. So summation of horizontal forces considering forces to the right as positive. So we have N sub S minus 4P plus P minus 2P is 0. N sub S is 5P. And then sigma S is N sub S over A sub S. The subscript S is for steel. So sigma S is 140. N sub S is 5P. A sub S is given to be 500 square millimeters. So P equals 140 times 500 divided by 5, and will give you P equals 14,000 newtons or 14 kilonewtons. Okay? So the problem is asking for the maximum value of P. So we have three values of P here: 10 kilonewtons, 36 kilonewtons, and 14 kilonewtons. So we are asked to find the maximum value of P that will not exceed a stress of 140 for steel, 90 for aluminum, and 100 megapascal for bronze. Okay, so from the three values of P, 10 kilonewton, 36 kilonewton, and 14 kilonewton, the word maximum doesn't always mean the biggest value here. So it only means that how much is the maximum P that can be carried by the system. So if we say P is 36 kilonewton, then it's okay for the aluminum. But a P of 36 kilonewton will cause the bronze part of the system to fail. So that means P should not exceed 10 kilonewton, because if it does, the bronze will fail. So our maximum P is 10 kilonewtons.